I found this book used at Barnes & Noble the other day, and I picked it up to read on a long trip. I just read Chapter 3 of the book. Chapter 3 was about global warming, and this guy, Richard Muller, now I had no idea of this at the time, but he was the head of a study on global warming, and so in that book he has a reference to this berkeleyearth.org, and I've actually already been to this website at least once before, but I didn't quite understand what it was. The point that should be made is a large chunk of this Chapter 3 was devoted to exposing the myths of global warming and pointing out a whole lot of just false statements that had been made by the IPCC and others. So it's kind of ironic that the first statement on here is they've just released an analysis of their land surface temperature records going back 250 years, about 100 years further than previous studies, and the analysis shows that global warming is real, and the best explanation of the temperature trend is a combination of volcanoes and carbon dioxide. So here's some frequently asked questions. What is Berkeley Earth's surface temperature? It has the acronym BEST. That's cute. I think the most exciting thing I found on this website was the authors of this material, available on the Berkeley Earth website, grant permission free of charge to authors, readers, and third parties to reproduce their materials as part of another publication or entity with proper sourcing to Berkeley Earth, and by additionally providing a link to the Berkeley Earth website. So that means that I can do what I'm about to do and show you whatever I find on here. Let's start with, why is the work being done by Berkeley Earth important? And it's because existing data used to show global warming have met with much criticism. The Berkeley Earth Project attempts to resolve current criticism of the former temperature analyses by making available an open record to enable rapid response to further criticism and suggestions. Our results include our best estimate for the global temperature change and our estimates of the uncertainties for the records. So it's our best estimate of what it is. They're not claiming it is the perfect estimate. They're just saying it's our best estimate. That's a reasonable statement to make. We believe that science is nonpartisan, and their interest is in getting a clear view of the pace of climate change in order to help policymakers to evaluate and implement an effective response. In choosing team members, we engage people whose primary interests are finding answers to the current issues and addressing the legitimate concerns of the critics on all sides. None of the scientists involved has taken a public political stand on global warming. Now, this is an issue that concerns me, and you notice that I'm gleefully taking this website and just spouting off exactly what it says. I can't generally do that. This is something that I can't do with the vast majority of climate science papers. I'm not allowed to read them online. I'm not allowed to make a YouTube video of me just reading the thing. So Berkeley Earth published its results paper in GIGS. I've never heard of that, but that's Sci-Technical Journal of Geoinformatics and Geostatics. And the point is that they don't feel that peer review is exactly what they want, because they say they know that experts in climate change are not necessarily the best people to evaluate novel statistical approaches. So I guess that's an important point. They're using a novel statistical approach to do this thing, and hopefully I'll get into that some later. I wanted to publish in a journal that would provide open access to the public, because the vast majority of the public cannot easily access reader pays journals, and I've gotten into that situation myself. I am frequently arguing on the internet and somebody posts a link to a journal that I can't access without paying $40 to read. And usually when people post links to things, it has nothing to do with my argument anyway, so as a poor person, I find something that is easily accessible very nice. Openness and transparency are core principles of Berkley Earth. This right here, I believe, is the most important core principle of any agency, and I think that is an important thing to put up front. Regardless of how much criticism these guys get, you have to remember that they are probably going to get more criticism because they've been open and transparent, and that is a really good thing. This is the irony about openness and transparency, is that once you have a leader that is open and transparent, then they will get criticized 10 times as much as those that aren't open and transparent, because people can actually see what they're doing to criticize them. And that's a good thing, actually, because you want things to be open and transparent so that you can criticize what's being done wrong and fix it. So Berkley Earth has only submitted papers to journals that provide open and free access to all. Now, I did not get that impression the first time I came to this website. I did not realize that, because I just went out to a link that had a 2-page abstract, and I thought that I still had to pay to get the actual paper, but I guess I was wrong. They got 3 detailed peer reviews from experts in the field. They incorporated their feedback, which they believe improved the paper substantially. They submitted it to another paper, the JGR, but they did not get accepted for peer review because they would not consider the submission of our results paper until after our methods paper has been published. And the much more detailed methods paper is being delayed. It's still being delayed because of its originality and complexity. They have asked many questions, largely because the mathematics techniques, although standard to statisticians, are new to them. So this is a big question. Has their methods paper been published? As this available? They said everything is available to the public. Is their methods paper available to the public? Because I'm happy to deal with a little bit of interesting techniques in a paper that somebody else hasn't looked at. I can make some judgments about whether things are, public should be able to look at stuff. Shouldn't we? It said delaying submission to JGR until after the methods paper is accepted would almost certainly have excluded Berkley Earth work from the next IPCC report. Some people think that peer review consists of submitting a paper to a journal and waiting for the anonymous comment of referees, but traditional peer review is much broader than that and much more open. Your first step is to present it to your colleagues by giving presentations, talks at local international conferences, colloquia, and by sending out preprints. See, all of the Berkley Earth papers were thoroughly peer-reviewed. We welcome the additional review of anonymous journal referees. And this is a good point. We feel our work should be judged primarily on the statistical approach used and the transparency of our analysis, not on the fact that we have been published in a peer-reviewed journal. And that's essentially how I feel. I've not been impressed by the peer review process. Of course, I really only know about the peer review process by hearsay. I know that there are some forums where if you go out and you try to discuss something with other people, they will delete your posts and stuff like that if you have not been published, or if there is no reference to it in a peer-reviewed journal, which seems rather like nonsense to me. Because if there's an idea that your peers haven't thought of and are going to reject out of hand if you discuss it, then there's no point in handing over your work to that set of peers. Now I'm going to jump to what seems to me to be one of the coolest things on the website, which is a video going through the years 1750 through the present, which basically gives a graphical representation of the temperatures that are being measured. And you can see that for a lot of that time, temperature measurements were only being taken in the eastern United States and a little bit of Europe and northern Africa, a few times in India there for a second. And then you'll see this will expand as time goes on, because, you know, more places started taking official measurements of temperature now. So that's why this goes back. This data goes 100 years back, further back than the Berkeley study. You'll notice you've got a lot more fluctuation in this area than there is later, because this data here includes almost all of the temperatures around the world, and so it doesn't fluctuate as much because it's an average. It's a mean temperature of all of the temperatures out there. This is a mean temperature of just Europe and the eastern United States, so it has a little bit more fluctuation in it because it's not including all of the data from the rest of the world. To get a better set, you go out to the NASA satellites and stuff like that to include the temperatures around the water. But I don't know whether to play all this through or not, because I'm not sure if you'll see anything in addition, but I'm tempted to play the whole thing. But what else should I talk about? (1988). 20 years old. Now I'm 30 years old. Look, it's getting red. Okay, so in the past few years, that's kind of an interesting thing right there. Oh, this one's a different one. Now, something that showed up in the book that I was reading but doesn't really seem to show up here is that each of these drops in the temperature are associated with happened at the same time as a large volcanic eruption. And in the book they had all of those dips labeled with a particular volcano. So it does say here that it's due to volcanic activity, but it doesn't have the dips labeled with the particular volcanic events that happened. I'd like to see that graph, but it's not. It's published in that book, but it's not published here, so I can't show you. Now, the simple fit based on carbon dioxide concentration is, if I remember properly, they said that the concentration of carbon dioxide is increasing exponentially while the temperature is increasing linearly, but the simple fit they did was basically to assume that the temperature was a logarithmic function of the carbon dioxide concentration. So the logarithm of the exponentially rising carbon dioxide levels gives you a linear graph. It says the Berkeley Earth team is making these preliminary results public. Okay, we've got papers that have been submitted for peer review, but they're already public. The Berkeley Earth temperature averaging process, commonly referred to the methods paper. So, okay, that answers the question that I had earlier. It is a new mathematical framework for producing maps and large-scale averages of temperature changes from weather station thermometer data for the purposes of climate analysis. It allows the inclusion of short and discontinuous temperature records, so that's like the that spot in India that was popping in and out, but didn't last for very long, so that nearly all digitally archived thermometer data can be used. Uses a statistical method known as kriging to interpolate data from stations to arbitrary locations on the Earth. An iterative weighting process is used to reduce the influence of statistical uncertainties are calculated by subdividing the data and comparing the results from statistically independent subsamples using the jackknife method. That's getting into some stuff that I would need to think about quite a bit more. Spatial uncertainties from periods with sparse geographic sampling are estimated by calculating the error made when we analyze post-1960 data using similarly sparse spatial sampling. Rather than homogenize the raw data, an automated procedure identifies discontinuities in the data. The data is then broken into two parts at those times, and the parts are treated as separate records. So I don't know exactly what they mean here, but let me guess. If I'm wrong, we'll try to correct it somewhere. But basically, there are times when temperature measurement is kind of a difficult thing to measure. So if you have if some of those places had a device that measured the temperature wrong, but regularly, then you might need to adjust the temperature there. But somehow an automated procedure identifies discontinuities in the data, and then the data is broken into two parts at those times, and the parts are treated as separate records. So they are going to play with the data a little bit, but they're going to have it all recorded as it is, and then do, well, I'm not sure what they're doing, but at least they're being transparent. That's the main point. And they're using their noggins to do the best that they can with the stuff that they've got, and they're letting people know this is what we did, or I assume they're letting people know what they did. They go ahead, and in this paper they give a description of the approach that they use. They made all this available publicly, so you can go out to berkeleyearth.org/pdf/methodspaper.pdf and check it out, see what you think of what they did. And I think they're not trying to pull the wool over your eyes here. They're really doing their best to explain every single detail. Here's a description of the jackknife method, apparently. And anyway, I think I'm going to wrap this up here, because if you've had the patience to watch 19 minutes of me talking about Berkley Earth, then you should be rewarded by some time not listening to me.